So today we're going to look at electromagnetic waves, synchrotron radiation, as well as production of light. So we've spoken about electromagnetic waves before. Remember, electromagnetic waves is anything that is part of radiation. It gives us various parts. As we can see on here, you have different frequencies that you can look at, and they produce different wavelengths. Remember, they're inversely proportional. What I mean by inversely proportional is the longer the frequency, the shorter, the shorter the wavelength. So the same thing holds true with the other way. Now, gamma rays, which is one of the radiations we recently explored, is a type of electromagnetic radiation. You also have X-rays, UV light, visible spectrum, infrared, all the way down to radio waves, which have the longest wavelengths. So, in terms of what we're doing with the synchrotron, now we're mainly exploring the Australian synchrotron, not so much the other synchrotrons, okay? A synchrotron basically produces light, so some kind of electromagnetic radiation, in order for us to see different objects. So to do this, you have a bit of a convoluted process. What you do is you firstly shoot an electron that kind of goes into here, this belt, and then it spins around, and you might notice there are these bending magnets. These bending magnets basically speed it up, right? And because it's in a curve, and electrons would usually only shoot in a straight line because it's a particle, you would have to speed it up, but then push it back in. So as you push it back in, it spins and spins and spins, and it goes faster and faster. As it goes to a certain speed, it gives off light. So we then collect these beams of light right here, and then we use that to view different objects. So why do we use it? The light produced has a really broad range. So this is the range, and we can see everything from this section downwards. So as you can see, we can see stuff that's really small. So let's say you go down, here's a fly, the next one there is a microbe, and then you can keep going down, you can see down to an atomic level. If you can see cells, viruses, proteins, atoms, then you can do various things. I think from memory, one of the researchers from recently allowed us to see cancer cells. And you can probably detect different things about viruses as well. You can actually tune the frequencies to adjust it to whatever you want. And obviously you can have really high intensity, so it's really bright. Usually with anything that has really high energy, so when you're moving an electron really fast, it has a lot of kinetic energy. We converted that energy into light energy, so it must become really bright. And you can tune it to a specific frequency, as you can see there. So basically, that's what we use the synchrotron for.